Hello, I'm Gerry Spencer from Nicole Nicholas Sharon School in grade 4. My project is about pendulums. A pendulum is a thing that swings back and forth which helps keep time. This is a grandfather clock. It uses pendulums to help keep timing. My question is, how does the length and the weight of the pendulum change how it swings? I think that the length, the shorter the string is, it will go slower, and I'm not quite sure about the weight. I built this pendulum to help with my experiment. First, I made this wood beam out of wood. I also added strings from different lengths from 1, 2, 3, 4, and 5. Each length has wire at the end of it with washers on the end. Each washer is about 4 grams in weight. I built the pendulum with 5 different lengths of fishing wire and hooks at the end to hang washers. With my tablet, I timed how many each length swings in 30 seconds with one washer. I did this again 2 more times. Then I did this again with 2 washers and then with 5 washers. The lengths are 26.4 centimeters, 20.1 centimeters, 15.5 centimeters, 13.8 centimeters, and 11.6 centimeters. I did this over several days. I also measured how many times my siblings and I swung on our swing set in the backyard in 30 seconds. This swing is also a pendulum because it swings back and forth. The difference between my 5 different lengths is that each one has a different length of string. One has the longest string, as 5 has the shortest string. Let me show you an example of timing one of my strings. After I do one of the rounds, I will add on more washers, then more after that. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Now I'm going to put on another washer to have 2 washers and see if there's a difference. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Now I'm going to add 3 more washers to have 5 washers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So that was roughly about the same, which is why the weight didn't change anything, but the length of each string did, because each string might be a bit faster or slower than one another. Even if I put 1 washer, 2 washers, or 5 washers, the results were about the same. This chart shows what my results were for the washer trials, with 1 washer, 2 washers, and 5 washers. Pendulum number 1 was roughly about 30. Pendulum number 2 was roughly about 34. Pendulum number 3 was roughly about 40. Pendulum number 4 was roughly about 42. And pendulum number 5 was roughly about 47. These are my results for the washer trials with 1 washer, 2 washers, and 5 washers. Over here I plotted it in this chart, which shows the cycles and the string length. The lines stand for each trials with either 1 washer, 2 washers, or 5 washers on each string. Over here I put it in this chart, which shows how many each cycle is per swing. And this one also has the string length in it. I wanted to see if I could make this line straighter, so I tested my sisters and me on the swings. The swing length was 150 centimeters long. These are my results for the swing trials, which are all about 13 cycles. This data shows my data for my washers on my pendulum and over here for the swing set. This data is the same data over here, but just with the swing set in it. This line doesn't look straight because most of it goes off, which makes it not a straight line. Since this relationship didn't work, I thought that I could try squared. Squared is when you have a square and you take 2 sides of the square. You times them each other and find the area. That's called centimeter squared. Over here I have periods squared in this chart with my washer trials. Down here it has the string length. This looks like a straight line since it's using squared. This is just using the washers I had on my pendulum. Maybe it might work with the swings. I have this chart here shows the washers and the swings. It has the period squared on the vertical axis and the pendulum length on the horizontal axis. It looks like a straight line. This with the period squared, it's a straight line, and even with the swing set in, still straight. But when you take the squared out, it's like this curvy line, which we have this so you can know that this is what it looks like when it's not squared. So for example, let's take 70 centimeters. So it goes up to 1.6 seconds. So that's how long each cycle would be per cycle. In conclusion, I learned that the length matters and not the weight. The shorter the string is, the less time it takes because it has the less distance to go. The longer the string is, the more time it takes because it has more distance to go. Thank you for watching.